أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم.
Quadratic effect. In this session, we are going to check one of the assumptions of SCM models. Normally, when we are running our SCM models, we assume the relationship between variables to be linear. Now, it is one of the robustness checks that one needs to perform before conducting structural model assessment. Next, we are going to perform quadratic effect, or we are going to assess the linearity. Now, whether or not the relationship between variables is linear. Now, if the relationships are linear, then our assumption is substantiated. Now, in order to do so, what we need to do is we are going to use this quadratic effect in SmartPLS to check whether or not the relationship between variables is linear or not. So what you are going to do is click quadratic effect, and then you will have these small boxes here, and that will ask you where do you want your quadratic effect. Now I want to check it for all relationships, so I'm just going to click here and keep on clicking till you add the quadratic effect for all the possible relationships. Now once that is done, you simply need to go to calculate, bootstrapping. The recommended is between 5,000 to 10,000, two-tailed, bias corrected, and simply press start calculation. Now here are our results. Now look at this. P-values. Now these are your P-values. I do not see any significant ones, but to be sure, go to path coefficients and see this, the quadratic effects. All of them are insignificant. This means that these proposed relationships, the assumption of linearity is met. The quadratic effect needs to be insignificant. Now, one of the robustness test checks out. So, the relationship, the assumption is met. These relationships are linear. Why linear? Because if you look here, these are insignificant. So, your quadratic effect, that is a particular variable multiplied by its own value and then its effect on the outcome, that is insignificant. So this is how you can check linearity of relationships in SmartPLS. The next step in robustness checks is assessing the endogeneity. Now we want to assess whether there are issues of endogeneity in our model or not. Now to do so, we are going to use a Gaussian Copula. Now what we do is we click here on the Gaussian Copula and you get these little rectangles or small boxes that say click. Now the procedure is that you start with individual relationships. Now each of that individual relationship is checked for endogeneity. Now once each of the relationship is checked, then you start checking the combination of relationships. So I start with one relationship, then I move to two relationships, then I move to three relationships, then I move to four relationships, howsoever the number is in your model. Now how to do this with this complex model? So what we can do is individual relationships, so just one. Save it. Now calculate, bootstrapping. Now for now, I'm just going to keep it 1,000. Normal recommendation is 10,000. I'm going to do a quicker one and let's start. Now in this case, let's go to path coefficients. And this is insignificant. What you need to do is you need to copy this row into Excel. So here, I do not need these. Delete. And here it is. Now GC com arrow TL. What does it mean? This is your exogenous variable, TL is your endogenous variable, and this is the Gaussian Copula. Now, next, I'm going to remove this one and I'm going to add it to the other relationship. Let's say this one. And now I'm going to run it again. Bootstrapping. And you can do one-tailed if you want. Let's say start, because I know the possible direction of relationship, so it's better to use one-tailed. Now again, go to path coefficients. And this one is significant. So you've got endogeneity issues here. Now, how to solve them? And that is part of another video. We are going to discuss it later. Now, this one is done. Now you are going to remove this. Obviously, you will copy the results from the output into Excel so that you can have a final picture as to what are the problems or where are the problems. Now, when you do single ones, the next step is to do a combination. So let's say this with this. So now we are doing two copulas or two relationships are assessed for endogeneity. Again, run it, calculate, bootstrapping. Now go to path coefficients. So here the same old relationship with problems, and this one is no or has no problems. Go back. Now you've done this one with this one. Now again what you're going to do is delete this one, and now Gaussian Copula. So previously I did the combination of this relationship from commitment to leadership and leadership to reliability. Now I'm going to do this, the other relationship. Now this is the next combination. Now similarly you're going to do this with every other possible relationship. Now once you are done with two relationships or the combination of two relationships, then you are going to move to combination of three relationships, and similarly you are going to move to combination of four relationships. So all possible relationships are assessed for endogeneity. And once you do that, you will have something like this in a table. And this is the paper. I'll share the link as well. Structural Model Robustness Checks in PLS SCM. And if you look at this table here, so in this case, assessment of endogeneity test using Gaussian Copula approach. And in this case, the copula was on just one relationship. Again, one relationship. Again, one relationship. Now, once they were done with single relationships, they had it for two relationships. Now, once they were done with two relationships, now here they are done with two relationships. Next, they had it for three relationships. And where is the model? Here is the model that they applied the endogeneity tests on. So you assess it for single relationship, all single relationships, then combination of relationships, so all possible combination of relationships, and then obviously two relationships, three relationships, four relationships. And if your p-values are over 0.05, this means that there is no issue of endogeneity. And this is the second step in assessing the robustness checks or testing your model for robustness. Next step in the process of robustness checks is to assess for heterogeneity. Unobserved heterogeneity. Now, latent class techniques for identifying and treating unobserved heterogeneity have a long-standing tradition in PLS SCM. Unobserved heterogeneity occurs when subgroups of data exist, which entail substantially different model estimates. Now, in such case, estimating the model based on the entire data set is bound to produce misleading results. For example, the positive and negative effects in each group could cancel each other. Now, in order to avoid such situations, before you go on and analyze data, you have to assess your data for unobserved heterogeneity. Now, to do so, we've got a procedure called FIMIX in SmartPLS. Now, how do we perform this procedure? This is the objective of this particular session. Now, previously, we have assessed the endogeneity and the linearity assumption as part of robustness checks. Now, there are a few selection criteria that we have to look into, and they are recommended by Sarsted. And we are going to look into AIC with factor 3, AIC and entropy, and some other requirements or other criteria as well, in order to assess whether there is a problem in your model or not. To do so, what I've got a model here, and this is slightly different from the earlier examples in robustness checks because this is a complex model, and further it had a higher sample size as well. Now what we do in case of FIMIX is that we divide our whole model or our whole data set into segments, and then we run the model for each number of segments. So the first step is to decide how many segments do you need to assess the heterogeneity. Now in this case, the first thing that we need to do is we need to find out the sample size required for each segment. Now what they have done here is, in this paper, they have taken the sample size as 85. Now there is a reference for it, which we've got in another paper here. The effect size 0.15 medium effect and the power of 0.80 are the input parameters, and this is the recommended setting in social and business sciences research. So if you use this particular setting, your sample size for each segment should be at least 85. So in this case, my total sample is 340. So if we divide 340 by 85, what we get is around 4 to 5 segments. So I will need 4 to 5 segments in my model in order to find out whether we have got any issue or not. Now in this case, what we are going to do is we are going to use this particular recommendation of medium effect with power of 0.80. Now in this model, I've got a sample size of 340, if I'm not wrong, yeah, 341. Here it is. So data 2, 341, yes. So if you divide 341 by 85, you get around 4 or 4. So I've got to run 4 segments. Now how do I do this? In order to do this, what I need to do is I will go to calculate, FIMIX or finite mixture segmentation. Now I need to run 1 to 4 segments. So segment number 1, let's see what our results are. Keep other as default, just start. And I will need an Excel sheet along with it. Open. And what you need to do now is, once you get the results for segment number 1, go to model selection criteria and you will see different results here. Now you do not need all these. We are going to use the common ones, and I'm going to show you which ones are those. Just copy it to Excel, new Excel sheet, and paste it here. Now these are the results when you've got one segment. That is whole data analyzed all together. Now you've got different model selection criteria. We do not need all of them. Let's use the ones that are common. Let's delete this. Let's delete this one, delete this one, and let's look at AIC 3 and CAIC, and then AIC 4 and BIC. So AIC 3 with BAIC, AIC 4 with BIC. So you do not need this one either, but let's have it for now. So we need this one. We do not need this one as well. So let's delete it. So for now, let's keep it. So let's now go for the next segment. Go back, calculate, finite, and this time it's 2 segments. So what are the results for 2 segments? Model selection criteria, copy, and paste it. Now again, we do not need this, and this. let's do segment number 3 and 4. I'm just going to do that quickly now. Now I've got 4 factor solution. This is number 2, this is third segment, and 4 segments. So here are the results for 4 segments. Now just double check you've deleted the right way. Delete, and let's arrange the results now. Let's delete these columns. Now once the columns are deleted, the next step is to see what's the minimum value here. Now in this case, the minimum value is this one here. So let's bold it. What about AIC4? Where is the minimum value? Here is the minimum value. What about BIC? Where is the minimum value? Here is the minimum value. CAIC, the minimum value is this one. Now the next step is MDL5. Let's see, the minimum value here is this one, and entropy is greater than 0.50. So this is pointing to more than one segment. Just hold on, we have to see other results as well. Now, so how do we assess the results? The result of the fit indices for 1 to 5 segments, now in our example it's 1 to 4. They provide an ambiguous picture. Now what we need to do is, in our case we have 1 to 4 segments. Now how do we interpret it? So as shown in this example, we have to first see AIC3 and CAIC. What do they provide us, or what are they showing us? AIC3 and CAIC. Now let's look at this. AIC3 and CAIC. So what I'll do is I'll cut it from here and paste it here. Now AIC3 is pointing towards 4 segments, CAIC is pointing towards 2 segments. So they are pointing towards different number of segments. So AIC3 is pointing towards, in our case, 4 segments, and CAIC is pointing towards 2 segments. The lowest value is here and this one is here. Now let's move on. Now further, AIC4 and BIC generally perform well when used to determine the number of segments in FIMIX. Both criteria point to a 2-segment solution. Now what is our case here? AIC4 2-segment solution and BIC 2-segment solution as well. Okay, moving on. The minimum description length MDL5 also points to a 2-segment solution. Now let's have a look. MDL5 here. Look at this, MDL5, the lowest value here. So what is our case here? MDL5 1-segment solution. So the problem here is that it's ambiguous. Now the issue here is that we have a recommendation for different number of segments. Now what happens is, jointly the analysis do not unambiguously point to a specific segmentation solution, because AIC3 and CAIC point to different segments. MDL5 also points to different segments in comparison to AIC4 and BIC. Now what's happening here is that you are getting a different number of segments for these model criteria or the indices. So in this case, since it's an ambiguous picture, what we are going to do is we are not going to create segments for further analysis, and we are going to analyze the whole data together. So there is no issue of unobserved heterogeneity in our results.